Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I hope you are all very well with a great health. Today we will start our new topic of chapter number 18, that is radioisotopes and its uses. As it is very clear from the name that the radioisotopes is the combination of the two words, that is radiation and isotopes. So the isotopes are the two or more forms of a chemical element having the same number of protons or the same number of atomic number but having the different number of neutrons. So this is called the isotopes. And the isotopes which are unstable and emit radiations to become itself stable are called the radioactive isotopes, or simply we can say that radioisotopes. So there are many uses of radioisotopes. So a radioactive isotope behaves in just the same way as the normal isotope chemically, which make it useful in wide variety of applications. Over 2000 radioisotopes either exist in nature or have been made artificially by bombarding stable isotopes in particle accelerators. Now, few of the uses of radioisotopes are discussed one by one. Like food preservation. The food irradiation is a method of treating food in order to make it safer to eat and have a longer shelf life. Even after it has been packaged, gamma rays can penetrate the packing and be used to kill bacteria, mold, and insects in food, as shown in the figure. That how the gamma rays are injected into the food to kill the bacteria, as you can see in the figure. The second one is sterilizing. The gamma rays are also used to sterilize the hospital equipments by irradiation, especially plastic syringes that would be damaged if heated, as shown in the figure. So you can see the figure that there is an apparatus to use to sterilize the medical equipments by using the radioisotopes in an apparatus. The third one is the agriculture. If a plant is given fertilizer tagged with radioactive carbon 14, then the plant releases beta radiation. And thus, by measuring radioactivity in different parts of the plant, the uptake of fertilizer by plant can be determined, as you see in the figure. This technique has helped in elaborating the complex process of photosynthesis as well. The higher yield varieties of seeds have also been developed after mutation through radiation. So here the soil containing the radioactive fertilizer which is absorbed and movement of the fertilizer is detected on the detector. The another use is of the medical use, which has a very wide range in our daily life. So the radiopharmaceuticals drugs that contain the radioactive material are important in diagnosis and treatment of many diseases. They can be injected into the body, inhaled, or taken orally as medicines, or to enable imaging of internal organs and bodily processes. Ionizing radiation has two very different uses in medicine, for diagnosis and for therapy. The medical diagnostics. Every organ in our bodies acts differently from a chemical point of view. Doctors and chemists have identified a number of chemicals which are absorbed by specific organs. For example, the thyroid takes up iodine and the brain consumes quantities of glucose, and so on. So with this knowledge, the radiopharmacists are able to attach various radioisotopes to biologically active substances. Images are then obtained via gamma camera or a PET scan in nuclear diagnostics, which enables to accurately detect disease progression and staging in vital organs. So, a radioisotope used for diagnosis must emit the gamma rays of sufficient energy to escape from the body, and it must have a half life short enough for it to decay away soon after imaging is completed. The another use of radioisotope is the radiation therapy. So high energy radiations can be used to destroy the selected tissues such as cancerous tumor, for which we use the cobalt 60, which is the radioisotope and which emit the beta particle, and high energy gamma rays can be used to treat the various cancers. Some radioisotopes are made to absorb by selected organ, and radiation is concentrated on the infected tissue. For example, cancerous thyroid can be treated with iodine 131. The another use of radioisotope is radioactive dating. The archaeologists and geologists use radioactive dating to estimate the age of ancient objects. One common procedure uses carbon 14, which has a half life of 5730 years. As long as the creature is alive, it will continue to absorb and collect carbon 14. This carbon 14 is a radioisotope. But once the creature dies, no further carbon 14 will be ingested, and the proportions of carbon 14 will start to decline. So, in the radioactive dating, the materials with relatively longer half-lives can be used to determine the age of geological formations. For example, uranium 238 with a half-life of 4.53 into 10 raised to the power 9 years can be used to date even the oldest deposits on the earth. As you see in the figure, that the deeper we dig, the farther back in the time we can see. So this is all about the radioisotopes and its uses. I hope you are very clear with each and everything. Stay home, stay safe. Allah Hafiz.